So hello everyone, welcome back to the another lecture. So in this lecture we will talk about the electric shock. So you all know about what is shock, what is electrical shock, but there is some confusion in people that when shock will happen and will not. Okay. So in this lecture we will talk about all the scenarios from basics to some advanced thing that in what circumstances the human body or any other animal may feel shock and it will cause some serious issue to his health. Okay, so this thing we are going to cover. So my name is Ashish and let's get started with this lecture on electric shock. In this lecture we will see what happen when human body and other animal touches the electric wire. Okay, that is a live electric wire. So let's get started with this. So, firstly, we will see some theory part that what is electric shock, how this electric shock will come and all. So, this thing we will cover first. So, what is electric shock? So, electric shock occur when an electric current passes through a body causing an immediate reaction or injury. Okay, that is a electrical current passing through a body. Then the electric shock will occur, and because of this, what will happen? Because of this, some injury may happen. It happens when a person come in contact with the electric energy source such as live wire, electrical appliances or lightning. So you can see this figure that if some faulty wires are there where insulation is not proper and if person touches it, that time the person will feel the electric shock. Similarly, if the equipment is not properly grounded or not having isolation or some insulation is not correct, and if you touch that equipment, that time also the shock may happen to you. Okay, so that is why insulation is very important. What insulation is? So insulation meaning providing very high resistance, and you know V is equals to the IR, right? V equals to IR, and current always follow the minimum resistance path, right? So if you offer very high resistance value, then the current will not flow in that path, right? So that is why insulation we generally used, and this insulation what it will do, it will offer very high resistance path. Okay, so this is about the electric shock. Now what are the key aspect of electrical shock? You should know that what are the causes of electrical shock. So electric shock happen at what particular instances, right? So what are the different instances when electrical shock may happen? So direct contact with the live electrical conductor, if you directly contact with the live wires, then that time if the insulation is not that good, then you may face the shock. Then faulty electrical equipment we have seen. Then improper wiring or damaged insulation, the same thing I have talked to you. Then environmental condition like the wet area increasing conductivity. Okay, so there are two cases. First is a dry case, another is a wet case. So dry body generally offers very bit of higher resistance value compared to wet body. If body is a wet, its resistance is decreases, and because of this the chances of getting electric hazard is increases. Okay, so this thing you should keep in your mind. Second thing, what are the severity of the shock? So severity of the shock depend on a few things. What are those things? Voltage, what value of the voltage you are come in contact with, what value of the current you are come in contact with, what is the path of the current, like how you have touched that faulty equipment or wires, and how the current is going to flow. So all these things are very important. Okay, then duration of contact, so for how many time or how long you have touched in contact with that thing. So these things are very important. Then body resistance, whether your body is in a dry condition or in a wet condition, so these things are also affect. Okay, so this is about the severity of the shock. So now what value of the current is sufficient to give you electric shock? What value? If you know, just comment down it. If you don't know, I will tell you in upcoming slides, but you should know that as an electrical engineer, what ampere of current is sufficient for us to have a high risk electric shock. Okay, that will may give to fatal. So what is that value? So you should know. If you don't know, just continue this lecture, you will come to know. Okay, so what are the key aspect of electric shock we have learned. Okay, now next thing, the human body resistance. You should know what is the value of the human body resistance. So this is one of the figure I have taken. So this is a just a animated photo. So human body. Now there are the different cases. Now what is the hand to hand resistance? If I have some wire here, okay, and if I have connected like this, okay, if I touch like this, so this is the hand to hand resistance. That time it will offer the hand to hand resistance. Okay, so what is that hand to hand resistance? So this value in two different cases, when in the dry case and in the wet case. Oh, in the dry case its value is ranges from 15k to 100 kilo ohm. Okay, and in the wet case its value is ranges from 150 ohm to 1100 ohm. So you can see there is a very much difference, okay, in dry case and wet case. So that is what I am saying, that when the body is in a wet condition, there is a very high chance of electric hazard. Okay, and if your body is in the dry condition, you will get electric shock, but that is not of that level. Okay, so this thing you should keep in your mind. So this is the hand to hand resistance. Now what is the hand to foot resistance? So you should know about hand to foot resistance also. So for dry skin it is from 100k to 600k ohm, and for the wet skin it is from 100 ohm to 8 to 10 kilo ohm. Okay, so this is the human body resistance of hand to foot. So this is with respect to this hand and this foot. Okay, so this is the value. So you should know, if somebody asks you what is the resistance value of the human body, you should say that, sir, in dry case the resistance is different and in the wet case the resistance is different. So in the dry case the resistance value is much more higher, in a wet case the resistance value is bit of lower. Okay, so that is why there is a high chance when our body is wet that we got affected by electric shock quickly. Okay, so up to this point I guess everything is clear to you. Now we will move forward. Now impact of different value of the current. So you should know that what value of the current is sufficient to us to get basically will affect much more to us, right? So up to 1 milliampere, so tinkling sensation only. Okay, so if you have get a shock, or if you are working on some equipment where the current is of 1 milliampere level, or through some circumstances the current of 1 milliampere is passing through your body, that time only tinkling sensation you will feel. It is not that severe. Okay, now up to 15 milliampere extreme pain may happen. So you can see that it is in the milliampere range, still extreme pain may you suffer. Then up to the 0.3 ampere, so cardiac rhythm disturbance may happen or extreme pain you will feel. And if the current level is up to the 1 ampere, then your body may burn and may cause permanent damage or death. So 1 ampere of current is enough to burn your body, to may happen death. Okay, so this thing will not happen to anybody. So but these are the conditions that basically impact of the different current value on human body. Okay, so you should know. So 1 ampere current is enough. Okay, so be careful while handling the electrical equipment. Be careful from electrical hazards. So safety is very important. Now we will see this different scenario, and let's move forward. So let's move forward. Now the scenario 1. Okay, we will see the some different scenario, that when the shock will happen and when the shock will not happen, what value of the shock or current may flow through our body, and what protection we can, how precaution we can take. Okay, so let us take the scenario where we have some 2-wire system and a person is here which is on the ground. Okay, and the person is without chappal or shoe, so he has not wear anything. Okay, so if this person is come in contact, so what will happen? So only one hand of this person is in contact with the wire. So what will happen? The current is initially flowing through air, right? Now as the human body, if in contact with the wire, so current will start flowing through it. Okay, current will start flowing through it, and through the human body the current will flow, and through the ground it will come to the again my neutral wire. Okay, because this is also kind of the ground. So this is ground, so my uh, leg, that human leg, and this ground are on the same potential, so current will flow like this, and that person will experience a shock. But what severity of the shock it will experience, so that will depend on the resistance of the human body. Now uh, if let us assume that this human body has a resistance of the 100 kilo ohm. Okay, so human body has a resistance of 100 kilo ohm. Now we know that how this supply 240 volt is here, right? So 240 volt supply is here, and I have my human body resistance, right? So according to I is equals to V by R, I can calculate the value of the current which is going to flow through this particular human body, right? I equal to V by R. I can calculate the what is the amount of current will flow through the human body. Now what value it will come? It will come nearby 2.4 milliampere. If I will do 240 divided by the 100 kilo ohm, it will come nearby 2.4 milliampere. So this much of current it will affect, and this current is not that much. We have seen that up to this current what will happen. So in this current 2.4 ampere, so only tinkling sensation we will feel. Okay, so this is not that high. Okay, but if this body is in the weight condition, then extreme shock it will may suffer, and because of this the death may happen. Now next case, scenario 2, when the person has wear a shoes. So if he has wear a shoes, and I am assuming here that the shoe has a resistance of 2000 kilo ohm. Okay, so and if this person right now if is in come in contact with the electric wire, now still it has a path to flow for the current, right? But what will happen? And in this way it will finish its path, right? But what will happen? Opposition of the resistance is too much high in this case. Body resistance is 100, body resistance is 100 kilo ohm, and additional this resistance of 2 and 2000 kilo ohm. So because of this very less current will flow, and because of this very small or very negligible kind of sensation this person will have, and there is not too much of shock scenario. Now third case is person is on the insulating mat. It is a very highly insulating mat. If the person is on insulating mat, and if he has come in contact with the electric wire, then what will happen? Current will try to flow, but there is a very strong insulating mat, so current will not allow to go inside this, because high insulation is there, high resistance will offer, and because of this person will not basically feel anything, right? So this is the case. That is why we always prefer to use shoes or use some insulating mat when we are working on any electrical equipment. Okay, so that is why it is generally tell. Now some next scenario we will see. So now scenario is like a person is here, right? And there is no ground in contact to the person. He is in some kind of floating. Okay. Now what is happening? The person has touches the two wire, one on the first wire and the line 2. Now what will happen? Extreme high current will flow, because directly it has a path to flow. Okay, and if it has so much of path to flow, directly person may directly death. So that is why generally don't put two hands on the two wires, because this if the insulation is not proper, you will directly may serve your life, directly you will gone. Okay, so that is why I generally it is very important to use the safety to work on the electrical equipment. So that is very important. Okay, so such thing the person will directly die. Okay, now next thing is, now person is here or floating again. Now what he has done, he has touched his one hand. Okay, so he has touched his one hand, so current will try to flow like this, but there is no path after this. So current, if current will not complete its path, what will happen? If current don't have path after this, where it will go? It will not go anywhere. So if current will not get any path, so because of this what will happen? If current don't have any path, it will not flow through the human body. It will come here and go back, but human body will not feel anything. And then current, once the current know that there is no path, so current always flow in the straight direction. So this is how, in this scenario, what will happen? Person will not feel anything if he touch only one wire, and if he is in a floating state. Okay, he is in a floating state. Okay, now next scenario is what person has done. Person has put his both the hand on the same wire. Now you know the concept of equipotential point. The potential at this point and potential at this point is same. So because of this, what will happen? As the person both the hand or an equipotential point, current will flow directly in a straight path. It will not try to flow here. Okay, even if he is on the ground, then also the current will not flow here, because both the hands on equipotential point. I am assuming here is that the resistance of the ground is 0. That is not generally the case. There is a resistance of the ground, but I am here assuming the 0. So in this case, when both the hands on equipotential point, the current will flow in the straight direction and person will not feel anything. Okay, so this is the case. Now next scenario, bird, where you can see that birds are sitting on the transmission line, right? And if the insulation is proper, then nothing will happen to the bird. But if the insulation is not proper, then that time what will happen? If the bird is sitting on one line, then again it's both the leg are on the equipotential point, so he will not suffer anything. Okay, because points equipotential point he is sitting, so no need to worry, right? So this is the case, just like the human case. But if bird is sitting on the one wire and his some part is also touching to the other wire, then that time the shock may happen to the bird and he may lose his life. Okay, so that is why when birds sit properly, when they sit, they either they sit on the one line only. So if the bird is sitting on one line, that time it will not suffer any shock. But if he is sitting on then that time it will suffer the shock. Okay, so with this I conclude this lecture. I guess you have understood that in what different scenario the electric shock may happen, and what value of the current is enough for human death. Okay, so be careful while working on any electrical equipment. Always have some safety, and I hope so you enjoy this lecture and you have learned something from me. Okay, so thanks for watching, and I will see you in the next lecture. So thanks for watching.